Good evening, everybody. Uh, am I clearly audible to you? Fantastic. So, good evening, everybody. I'm Sharvari Kulkarni, and I'm a technical associate at BDG Lifesciences. First of all, I would like to welcome you all to this 2 hour session of molecular dynamics and simulation. And it's indeed a great pleasure and motivation for our company to see enthusiasm with the participants to learn into the insights of molecular dynamics and simulation. And I assure you that these 2 hours will be really productive for you to learn what is molecular dynamics. Our purpose of the session is to make you understand what is empty simulations, and this will be a theory and live demo, and you can of course join our workshop which we conduct for the same subject. So let us begin with, already my introduction has been put up in the chat box. Still, I will briefly introduce myself and company. I'm Sharvari Kulkarni. I'm Technical Associate of BDG Lifesciences, and I have 12 years of experience in the field of biotechnology. I started my career as a manufacturer in Reliance Life Sciences, young manufacturing professional in Reliance Life Sciences. Then I switched to academics, in which I have 12 years of experience on different subjects like immunology, IPR, and bioinformatics. Then bioinformatics, I have been teaching from 12 years. In that, my area of expertise include basics and advanced of bioinformatics, then docking, molecular dynamics and simulations, and then QSAR techniques. Now I'm associated with BDG Life Sciences, in which we conduct different workshops on various topics. And this is about my introduction. Now I would like to introduce my company and some services of our company, and then we will move ahead with the topic. Now I'll start sharing my screen. Yeah. So let us start with MD simulations. I would like to start with BDG Life Sciences introduction in a brief. Our company is Biodiscovery Group Life Sciences, is established in 2009, and it is basically motive of the company is to create a group of students, researchers, scientists, professionals who are related to the field of biotechnology, bioinformatics, and pharma. Our group has our group has free consultations, tutorials, books, project reports, research news, and training job offers in India as well as abroad. I would like to brief about the company. Our company is, as I mentioned, we are specialized in the quality services of biotechnology, bioinformatics, pharmaceuticals to the clients. And our wide array of services include research projects, contract research, workshops online on site, training online on site, webinars, internships, contract research, seminars, and conferences. These are some services that we offer, mainly in the field of bioinformatics, basic and advanced, structural bioinformatics, gene and genome editing by using CRISPR, then drug discovery technology, molecular dynamics simulations, genomics and proteomics, NGS, artificial intelligence, machine learning, immunoinformatics, genome and mutation analysis, canceromics, R programming. These are some main services that we offer. I would like to proudly say that we are the first to introduce online training in drug discovery and designing, and we are also first to conduct training online on site in gene and genome editing using CRISPR, which is the topic in high demand in dry lab. And understanding the hard times, we are uh, glad to tell you that we have been launching very uh, good quality of free courses to facilitate the learning in the hard times. With this, I will also like to tell you that you can visit our website for viewing the feedbacks and success records of the company. Now I will move ahead with the objectives of the module. Now we are going to first see what is MD simulation. Now, first let us start with what are we going to study in this. We are going to see first what is MD simulation. Then we'll see installation of NMD and VMD. Then we'll see how to prepare input files. Then we'll see running the simulation for different conditions. Then the analysis and then plotting of the data. So this all we are going to learn step by step. And first we will learn all the process. Then I will give you one demo of the exercise. So I would start with what is molecular dynamics. First, let us understand what is the molecular dynamic means. What does the molecular dynamic mean? Molecular dynamics is a computer simulation method for analyzing physical movements of atoms and molecules. And it is the computational method that calculates the time-dependent behavior of molecular systems. So what is mean by time-dependent behavior? And let us first start with very basic. You all must be from life sciences background, but maybe you might be you're not aware of what exactly is biological simulation. Simulation in day-to-day word means to mimic the behavior of something. And molecular dynamic simulation is why it is needed basically is because we are applying all these techniques in dry lab, and that means we are mimicking the behavior of system in the dry lab. So in order to mimic the behavior of natural system in dry lab, we need to simulate it. That means we need to apply the system which is similar to our natural system. Okay, so for that we are applying the time dependent behavior of molecular system, how a particular protein will behave in different conditions as per the time dependence. So it will be giving us detailed information on the fluctuations and conformational changes of proteins and nucleic acids. So these methods have got a lot of importance nowadays because we can investigate structural dynamics and thermodynamics of biological complexes. Okay. So now let us see with the help of this diagram, it will be more easy for you to understand. We are applying this dynamics to a system which is made up of 10 particles. And we are going to study the time dependent behavior, as I told you, by studying these fluctuations of the particles from time step to time step. Getting means from one time step to another time step, how the IC and BC are getting changed. What do I mean by IC and BC? It's initial condition and boundary condition. So as you can see here, we are applying Newton's equation of motion for first initial conditions and then boundary condition. Time dependent behavior means at each time step, we are applying molecular dynamics, that means Newton's equation of motion, and then we are studying whole trajectory and time dependent behavior of the system till it reaches the stability. So the total time that you have selected, we will analyze at the end if the system has achieved stability or not. How to analyze that we are going to discuss in upcoming slides. So let us see first what do we need for simulation. So let's get started with the actual thing. Simulation is basically, I would like to compare it with any cooking recipe. So in order to make any good cooking recipe, what do? You have to prepare all the ingredients in right amount and in correct amount. Then only when your input is good, then only your recipe will be successful. So at the end, you'll get a nice, what you can say, product when your input is correct. So same is the case with simulation. If you prepare all the files of input correctly, you will run your simulation flawless and your is without error, and then your simulation results will be also accurate. So first stage is we are gathering all this input files. Okay. So the required programs for this are, first step is installation of software. So the required programs for this are NMD, VMD, NMD tutorial files, text editor, and plotting program. So I put the links for all NMD, VMD, NMD tutorial files, text editor, and plotting program. You can simply go to this links or you can Google it and install these softwares. But most important, many of the times people feel difficulty in installation of software itself. Sometimes they install on non-compatible format of NMD and VMD with the system. Nowadays, I'll show you which has to be installed correctly when I show you the demo. Okay, so you need to install proper version of NAMD and VMD. NAMD is nanoscale molecular dynamics, VMD is visual molecular dynamics. So this NAMD and VMD, they go hand in hand with one another. NAMD does not have its own GUI, that is graphical user interface. So it will be run through MS-DOS command prompt, and it is there in everybody's computer system. So you need not do anything extra for that. We will be accessing or calling the NMD from MS-DOS command line. So we will operate at a time both the command prompts, NMD command prompt and VMD command prompt. Okay. Then we will install NMD tutorial files from the website where you have packages of certain files, and those are required. Those are standard files we are going to use. And this, if you learn for one protein, you can apply it to any other protein or any other system. Okay. So I'll teach you how to make editing in the actual files in order to apply to your system. Then text editor. Text editor can be anything, notepad or wordpad. And the next is plotting program. Plotting program, actually VMD has its own plotting program, that is excellent. So we are going to see through the VMD all the plots, energy plots, temperature plots, and RMSD. But apart from that, if time permits, I'll also show you how to get the graph from Excel. So Excel can be also used as a plotting program. Okay. Now, as I told you what is needed, let us first make this thing very clear. If you move step by step with this, then always your simulation will be successful. So first thing that you require is always keep in mind standard PDB file of the protein. So PDB file is nothing but your atomic coordinates file, right? So in the atomic coordinates, what do I mean by atomic coordinates? 3D structure information of a protein, which is stored in the PDB database, right? And PDB database is protein database. So I think you all must be aware of how to download file from PDB. You have to simply write the name and download file from PDB. Today for the exercise, we are going to use ubiquitin protein. So we'll be downloading UBQ file of PDB version and save it in your working directory. Then next is PSF file. PSF file means protein structure file. It stores structural information. Now, what is the difference between PDB and PSF? PDB is it specifically stores atomic coordinates, and PSF file means it specifically stores the structural information. That means how these atoms are connected to each other. That is why your PSF generation or PSF file generation is very, very important step. It will tell the simulator or NMD that how the atoms are connected to each other, how the different bonds are involved in the interactions. So we are going to generate PDB file. We are going to get ready-made. From PDB file, we are going to use some scripting that I'll teach you, and then we are going to construct PSF file. Next important file is force field parameter file. What exactly is force field parameter file? It is the potential of atoms that the atoms experience. Now, there are three types of potential or force field parameter files which can be used in simulation: CHAR, AMBER, and EXPLORE. Different softwares are there for simulation. We are going to see simulation today by NMD, BMD. For that, we'll be using CHAR force field. Okay, we are going to use CHARM 27 version. There are now the latest version till 36 has been updated. Now, you have apart from CHARM, AMBER. GROMACS uses AMBER force field, and then you have EXPLORE. So basically, force field is also very, very important because it is very important to provide the system information about the potential of the atoms. Next important file is this force field parameter file is also standard file which applies to all the standard protein systems. That also we are going to get ready from the our package of NMD tutorial files. The next is configuration file. Configuration file is the file which we are going to use. So user specifies all the options for NMD. We are going to also see the standard configuration file. Most of the times you keep all the parameters which are there by default. Only the difference is you change the time step according to your need. As and when you practice, you will understand what is the time step required for the accuracy of result. Most of the times, standard is 100 nanoseconds. So for paper publications and all also, your 100 nanosecond results are sufficient. In the range of minimum is 50 nanoseconds, then some people run it for 2 femtoseconds and all also. So today we are going to run for 2 fps. Clear? So these 4 files you have to always keep in mind that we require. In the simulation, you have to always keep the checklist of files needed in your mind. You should not skip anything because that causes error. Now, next part that we would be discussing generation of PSF. As I told you, we require PGN scripting, and this whole thing is called as PGN scripting. It starts with package requires PSFgen. This all lines are, this is a comparatively simpler scripting, which specifies or which tells PSF generator to generate PSF file, and these file we are going to use henceforward. So in short, I'll just tell you meaning of all these commands in the script. Package require PSF gen. That means we will tell PSF generator to call PSF gen. Then the next file that we are going to call, as I mentioned you, our topology file. So top all 27 protein lipid input file is the standard file. Then PDB alias residue HIS HSC. That means alias means what? Instead of. So wherever in the topology file HIS is seen, it will change to HSC. Then alias ILECD1 CD. So there are certain standard formats of the residues also which are accepted by NMD. So uh, before we enter the simulation, we have to make this certain changes, and then accordingly we will generate our PSF file, and that file we will provide for simulation. So then you can see this last two lines important. Write PDB UBQ.PDB and write PSF UBQ.PSF. Okay, so these two commands will tell the PSF generator in the VMD to run these two commands and generate the PDB PSF files. So this is a screenshot of how we are going to access TK console. We are going to open it through VMD. Then this is how we are going to run the commands. We will run it through one build. I'm just to give you a flow of what are we going to do. We are going to do it as a demo, so that time it will be more clear. Now this is how you can see in brief our flow chart of simulation, how NMD, VMD and PSF generator are connected to each other. This is a topology file. This is a PDB file. This is PDB file residues, and this is PSF gen. This is PSF and PDB and your parameter topology file. All this is given together along with VMD to NMD, and NMD will tell us the results. So you can see this flow chart. Editing the PDB file. Sometimes you need to edit the PDB. For that, different softwares are there, like Swiss PDB Viewer. Edit means what? You have to remove some residues, you have to add some residues. That depends upon the purpose of your research, but most of the times it is standard. Then PSF generation. Then you can see here solvation of the target that we are going to do. And finally, by providing all this, we are going to perform NAND simulation. So the next part after PSF generation comes as solvation of the protein. So we are going to solvate the protein, or we are going to, what do we mean by solvate? Provide the water molecules, okay? Provide water molecules surrounding your protein. So ubiquitin in water sphere and ubiquitin in water box we are going to study. Fine. So for that we are going to use scripting of For that, we are going to use scripting of water sphere TSL and water solvate PSF in water box. So these are called as periodic and non-periodic conditions. Periodic conditions and non-periodic conditions. So periodic means water box. Fine. Periodic means water box. That means we are going to generate water box of certain dimensions surrounding the protein. And what is non-periodic? It is a sphere. So we are going to surround the protein with beautiful sphere of water molecule. So these are some commands which are needed to solvate the proteins. And then we are going to visualize the protein in VMD. So this looks like this. Very beautiful, isn't it? Now, after that, we will learn how to write configuration file. This is a sample of configuration file. So then after preparation of all the files, solvated files, we are going to run the simulation. And then we will analyze NMD plots, and then we will analyze after that RMSD versus time. This is how our command prompt looks. We will give the command and we'll get 11 output files. Out of these, two important files are DCD and PSF. And we are going to see how to analyze this DCD. Why DCD is important is because DCD gives trajectory of the atoms. So we will study the trajectory of the atoms by loading DCD and PSF files. This is how we are going to get plots of NMD like this. This is RMSD plot, and this is final structure of beautiful structure of protein that comes after simulation. So according to color scale, we can analyze the protein. So similar way you proceed in water box. Right? So this is the final structure after simulation. These are final RMSD over residues. Fine. So this is about what are we going to do in this session. Now I will give you demo of each and everything and how to write from the installation of the softwares. Fine. Yeah. So now I'll open first. I'll show you which all files are needed. First, I would always suggest, I'll also tell you some tactics and techniques and some, what you can say, uh, some simple techniques to or tips to remember. We can call it as tips to remember and run the flawless simulation. So what we will do is, first, I'll tell you one simple rule you remember. You always try to run the simulation and make the path as simple as possible for your simulation to run. So path of what? Path of installed softwares. So make it as simple as possible so that you don't come across errors. Okay. So what I do tell always to my participants also that you save everything in the D drive. You see my D drive here. So in D drive, I have installed and saved this NMD folder. Now, as I provided the links also, and I'll tell you, you can simply go to Google and install NMD. So this is the version. So in D drive, your NMD should look like this. Now, first, I'll tell you what all we need for the for running the simulation. So first you will install this NAMD 2.14B2. My system is 64, so I will use this 64 version multi-core. Now, one thing that you have to make sure, there are certain precautions that has to be taken care. In NAMD, when you open or extract it into D drive, these are all other files, but most important that you can ignore. Most important file that you should look for is NAMD2 executing file. Is that fine? So this blue color application file has to be there in order to run the simulation. This is our application file which we are going to access through command prompt. Then once you're sure that your NAMD is correct, go for NMD tutorial files. Once you installed NMD tutorial files after making a or after doing a Google search, you have to again see in the NMD tutorial files whether you have got all these folders. Okay, so I'll tell you what all you have to check. You will have to check if you have got this 11 build folder. In 11 build folder also, you will, this all we are going to generate. What you will get ready made is this 1 UBQ, PDB file. My this type is showing it as BioVR Discovery Studio because my installed soft because of my installed DSV in my system. So you guys will be having it as one UBQ PDB file. Okay. Then top all 27 file, that is our input topology file, that has to be there, and water sphere TCL file. So before moving ahead itself, make sure of these things, and so that you don't have to come back and check what you have missed or where you have gone wrong. So when you're moving ahead step by step, that time itself you keep on confirming whether you have got everything or not. So I like repeat once again, one UBQ PDB file will be there, top on 27 will be there, and VAT underscore sphere TCL scripting, which is needed for solvation, will be there. Then you can go back and check for 1-2 sphere, 1-3 box, that will be needed. Well, all these are extra. So these are according to your need, but main simulation will be running for sphere and box. Okay. Then you will have a common directory. I'll tell you its importance in the where it is needed when we are making it. Okay. So now this three, as I told you, you have to check for that, and also you will check if the common folder is there. Okay. So now you have NAMD, you have NAMD tutorial files. Next important thing that you are going to check for is VMD. You can install VMD painless. You have like it will be very simple. It will be installed. NAMD will take some at least 5-10 minutes. VMD will be installed quickly, and it will be installed in your system. Okay, so you have to simply type VMD in the search box like this. Can you see this? VMD 1.9.3, and we will open this. Once you open this, you should see these three windows. You get it? This is not required, but we are going to do everything in this main window and this graphics window. Okay. So once you make sure, I have opened it twice. Yes, so we are going to use this VMD main, and whatever changes we are going to do here in the extensions, we open TK console. Whatever changes we are going to, and this is our command prompt of TK console. So whatever changes we are going to make in the TK console, that will be displayed in the graphical display of VMD. Okay, now VMD is also done, NMD is also done, NMD tutorial files is also done. Now let us move ahead with the actual exercise, right? So let us go ahead. First important thing is we are going to open command prompt. So we'll open this command prompt. Deliberately I have kept largest font so that you all can see clearly how to operate the command prompt. Now, if you all, if many of you are operating it for the first time, as I told you, you have to simply write CMD in the command prompt, and always you have to navigate to the correct working directory. Okay, so we will move to the correct working directory first. Yes. So what we'll do is we'll write the first how to access, since we are going to work in 1-1 build. Always remember, in simulation, we are going to work first for the creation of files in 1-1 build. And after that, we will be running the simulation for respective, this thing, what it can say, respective conditions, right? Like water sphere and water box. Fine. Now, how to access the folder, correct folder, that we will see first. It starts with cd space 2 dots command. Then you go to D drive. As I have all the files, I told you my 11 build folder is in the D drive. So I'll open D drive. Once you are in D drive, then we'll go to NAMD dash tutorial dash files. Correct? Then you enter. Then we will access CD 11 build. Enter. Okay. Now once you are in 11 build, then only you will run or you will do the further part. So first important tip, you have to access correctly 11 build, isn't it? So once you have like correctly entered 11 build, you have to enter in the TK console of the VMD also at the same time. Okay. So let us minimize this and enter in the VMD TK console. The same thing. This is the working platform of VMD TK console. So here I'll do the same thing. CD space 2 dots, enter. CD capital D, D drive, CD NAMD dash tutorial dash files, enter. Then what should I do next? CD 11 build, right? Enter. Yes. So here also we have accessed 11 build. Fantastic. Yeah. Now till here, I believe everything has been simple and clear to you. Then we are going to generate now PDB and PSF. As I told you, we are going to use PGN scripting for the same. Now I'll tell you how to see this PGN file. You are going to create it manually. Since I have already done it, I'll just tell you first, or I'll just show you the PGN file. You will open the notepad and create the PGN file with this scripting which I shown you before, and you will save it in 11 bit. Can you see here? Yes, this file ubq.pgn. Yes, so this is the script for ubq.pgn. As I told you before only, the meaning of script. So you will save it as a text document. Fine. Once you save it as a text document, you're going to source this file through the TK console. Fine. So now I'll write the script for sourcing this file in TK console. Once you source this PGN file, then it will run automatically the PSF gen and we will get our PDB and PSF file. So for that you write the command of source ubq.pgn.txt. Okay. Fantastic. So enter. Fantastic. So now in one go, without any mistake, we have got our PSF file, which is completed. Right? Now, whenever you perform any command in the TK console or NAMD, you can always type simply dir. Okay, simply type dir and enter. That will tell if your files are generated or not. Now it's showing me PSF file generation is completed, but in the directory also you should see ubq.psf which is generated and ubq.pdb which is generated. So we have successfully generated these two files, right? Fantastic. So now, since we have got these two files, now what is the next requirement? That is the solvation of the protein. So I'm going to teach you, or I'm going to give you demo of how to solvate the protein in water sphere, and then you can apply the same way for water box. Okay. So now how to solvate the protein? We are going to solvate the protein in two environments. Like first is, why are we solvating the protein in first important thing is, it's because you need to provide water molecules which are similar to your cellular environment, right? So first we are solvating the protein in water sphere, that is with non-periodic conditions, and then we are solvating the protein in water box, that is your periodic conditions. So for that we are going to use script which is known as VAT sphere TCL script. I had shown you first this file. You remember this file? You can see here also VAT underscore sphere TCL. That is already there in your 11 build folder. We are going to source it. So simply write source VAT underscore sphere dot TCL. Okay. VAT underscore sphere dot TCL. Enter. Fantastic. So now it is solvating the protein in water sphere. Let us give it some time. Okay. Fantastic. So our protein has been solvated in the sphere. Now output will be solvated protein files in sphere. Okay, we will get solvated protein file in the water sphere that we can visualize also in VMD. So apart from that, you should see these solvated files will be named like this: ubq underscore ws dot pdb and ubq underscore ws dot psf. Okay. Now, apart from that, you will see the center of the mass of the sphere. This is the center and this is the radius. So we get the center of the sphere in XYZ coordinates as well as radius. Now we will save this or we will record this information, because this information of center and radius we are going to require in this information in the last, that is when we are running the or preparing the configuration file. There you will have to enter this information. Okay, again type dir and check if you have got the file. Yes, I've got this file, ubq underscore ws.psm. Can you see here? Yes, and ubq underscore ws.pdb. Fine. So now we are ready with what? Water sphere solvated files PDB, water sphere solvated file PSF. Then we have already our topology file. Then we will now go to the next part, that is configuration. Before that, I would like to show you in VMD how beautiful it looks. So, yes. So, no, this is previous file. Now I'll show you how to load this. this water sphere molecule. For that, I will delete previous file, and then I will load these files which are created in the VMD main in order to see it. So for that, always do file, new molecule. It will open molecule file browser. Now in the molecule file browser, you have to browse your files. Now this created files, as I told you, are in 1.1 build. You can go to 1.1 build and access the files. So you can see here, this is our PSF file. This we will load first. Open. Fantastic. So it's loaded. You have to click on the load. And next, we are going to load PDB file. So browse. Here we have our PDB file which is generated, right? So open it. Load it. Fantastic. So you have got this sphere file. Okay. So our protein is lying inside this beautiful sphere of the water. You can delete the molecule in the TK console. Fine. Yes. So this part is over. Now, one important tip again I'm going to give you is I had mentioned about the common folder. So in D drive, you have your common folder. In D drive, you have your common folder. This you have to see if it is there. Okay. In you can see here in NMD tutorial files, you have your common folder. Now, whichever files we have created, we are going to transfer it to common folder. Why I'm telling you to do this is because it will be simple to access one particular directory for NMD instead of searching to different directories. So we are going to keep single common directory where we are going to copy, listen to me carefully, we are going to copy ubq underscore water sphere pdb, ubq underscore water sphere dot psf, and we are going to copy our other files we have in 1.1 build. So you need not copy these two created files. Normal PDB file, that is UBQ PDB file, UBQ underscore water sphere PSF file, and UBQ underscore water sphere PDB file. Once this is done, we will see how to run the simulation in Sphere. So for that, running the simulation in Sphere, you need to see or you need to prepare configuration file that will be there in your Sphere. You will not be having all this. These files are the output files of simulation. So once you run the simulation, you will get all this. Now, I'll show you how to read this configuration. This is the configuration file. So in short, I'll tell you how to read the configuration file and what is the meaning of each and every term. So this always in a command or in any scripting, always you remember this symbol means ignore whatever part is written after this symbol. So if it starts with hash symbol, minimization and equilibration, this is for our understanding. NMD will not read this. Whatever is required for NMD, that files only it will take up. Okay, it is a very smart tool. Then structure and coordinates, as I told you, it is going to take from PSF file and PDB file which is stored in the common directory, right? Then all other parameters are default. I'll tell all this in detail in our actual course or workshop of MD simulations. Here, because of the time constraint, I'll just show you the file and tell you important parameters. So this is the important, that is how much runtime is required and how much time steps you are considering. Each time step of my simulation will be consisting of 2fs. 2fs, you can imagine how, means what is the division. 2fs is 2 into 10 raised to minus 15 of the seconds. So 10 raised to minus 15th part of the seconds. Then I'm going to run it for 2500. So if you make this calculation, it is around 5000 of picosecond, 5000 of fs, that means 5 picoseconds. Okay. So this is, you can keep it as I told you in the beginning itself. It's up to you. How do you keep this time step? You can keep it from 20 nanoseconds, anything. Okay. Now, once you make sure that you have your configuration file in 12sphere, we are now ready to go. Right? Now we will access this command prompt. In the command prompt, now we are going to access 12sphere. Okay. Now we will access 12sphere. For that, always remember, for accessing 12sphere, you will first have to go to NMD tutorial files. Now I simply write here CD 12sphere. It will give me, wait, I'll show you what will happen. If you write here directly CD 12 sphere, it will give me system cannot find the path specified. Then you should understand what mistake I have done. I have to go to the previous directory. So for that, I'll have to put cd space 2 dots, enter. Now I'm into NMD tutorial files. Now I'll write cd 1-2- correct? Enter. Now, once you are in 12sphere, now we will write, since we have made all the ingredients ready for simulation, now what we will do, we will write the command. You have to put this command very carefully. You are not supposed to make it is case sensitive as well as space sensitive. So you have to make sure, read the command always in, be it a modeling, be it a docking, be it a simulation. Always read your command and enter. Before entering, spare your time for 5 minutes, 10 minutes in reading the command. No problem. But it will avoid the error which will be caused because of, which you tend to cause because of the ignorance. So fine. Now I'm going to enter the command for running simulation. It's capital D dash backslash. Now I'm going to call my software, that is NMD. Here also make sure that your version is correctly entered. Otherwise it is going to give you error. Okay. So 2.14 B2 underscore capsule win 64 dash multi-core backslash. Now here you see here carefully, this NMD I'm writing in small. This, what is this NMD2? The file which I had told you to be careful if it is present or not, your application or executing file. So now NMD2 space, we are going to write the names of files. UBQ underscore WS dot EQ WS dot EQ dot CO, sorry, ws underscore dot uh, eq dot conf space greater than symbol, then space ubq underscore ws dot eq dot log space and yeah. So one more time, I'll check if the command is correct. It's capital D semicolon NAMD 2.14B2 Win64 dash multicore slash NMD2 space UBQ underscore WS dot EQ dot CONF UBQ underscore WS underscore EQ dot log space and wait a minute. Yes. So now we will, once we are sure that our command is correct, now we can simply press enter and run the command. Okay. Yeah. Now I am sure that my command is correct with all the titles of the files which are required. Now I'll press hit enter. Fantastic. Now without any error, it has started. You should see it blinking here at the left bottom. Now our system has started running the simulation. Now what will happen after, depending upon the configuration of your system and depending upon the speed, it will give us 11 output files. So what we will do, we will not wait till it gives. I'll show you the already created files, how to analyze them. Till we complete the analysis part, we would have generated here our files, and then I'll show you what or how you should read the files if you have correctly generated or not. Now let us give this some time to NAMD simulator to run. I'll minimize this. Now we'll move ahead with analysis part. I'll show you in the directory how it will come with the previously created files. In 1-2 sphere, our simulation is running. So in 1-2 sphere, we are going to get these files. Fine. So out of this 11 output files, we get two important files, which are DCD file. Here you can see this DCD file and this file, text, that is your log file. Okay. Your log file and DCD file and PSF file. These three important files. Why DCD file? Because DCD file is needed to analyze the trajectory of the system. So this DCD output file is going to tell us how to analyze the trajectory of the system, and this text document is our log file. This log file is going to tell us how you have got the energy distribution or difference in energy pattern of the system. So I'll show you these files first. This is your log file. So very big file. I'll just tell you how to read it. Yes, so this is how from the zero time step you have got all the energy data: bond energy, angle energy, dihedral energy, improper energy, electrical energy, all this energy data, kinetic energy, total energy, temperature, all this data till your 2500 step. At the bottom you can see. Okay, this is your last step, 2500, and its energy data. Now you might be wondering that do we need to read all this? No, we are going to plot this directly in VMD main. Okay, so we will analyze it in the form of graph. Then the next which I mentioned is DCD, and the other one is PSF. So I'm going to load all these files one by one in the analyzer to analyze the output of our simulation. Fine. So now we will operate this VMD. Now I'll see first whether I am in 1-2 sphere or not. Okay. Yes. So now what we'll do is we will load our files in this VMD main. So first let us load for analysis. Go to extensions, then go to analysis. Now what are we going to do is we are going to load the log file. So for that you go to NAMD plot. This will open one window. Here you go to file and select NAMD log file. Now the file which we have generated, we are going to access it here. Since I told you we are still running our simulation, I will show you the already installed or already uh, stored output, saved output file. Okay. So this is my log file. I'll open up. Yes. Fantastic. So it has been loaded. Now you have to select one by one each factor. So at a time you can select this temperature and total energy, and then go to file, plot, selected data. Fantastic. So it gives you this graph of total and temperature. Okay. So you can see here this energy variation. Now you can see very nice simulation has been done in this case because it has achieved the straight of line after some particular time step. So less is the energy. It should be always. How do you interpret if the system is stable or not? This is on the basis of energy. If it has achieved certain global minimum, then local minimum, sorry, then you say that the system has achieved stability. Also, it should retain certain stable values. So you can see this graph of total energy. It gives you certain stable value. Now you can go back and get other graphs. Same way, you can select uh, electrical energy, file, not selected data. So you get electric energy graph. You can verify it this with the log files, isn't it? So this is how you get the analysis. How to analyze this is with the help of graph. So this is about the NAMD plot. How do you analyze RMSD? Is with the help of one visualizer tool which is there in the VMD main. So for that, in the extensions itself, first we will load our two molecules here. Which two files will be needed? I've already mentioned DCD and PSF. So we will go to File, New Molecule, browse our output DCD file and PSF file. Fine. So first we will load DCD file. These all steps as well as the sequence of the steps is also important. Okay. So you have to be very specific about it. First, we will load this DCD file which is generated. Open, load. Then we will load PSF file. Okay. Yes. So open PSF file. Load. Yes. Fantastic. So this is the loaded protein. Now we will go to extensions. Then we will go to extensions analysis. Then we'll go to RMSD visualizer tool. Okay. In the RMSD visualizer tool, click on, you have this 10 frames, then you can select the frames, but you keep everything default. Make sure that your atom selection has done. It should be protein. It should be written as a protein. Then you go to RMSD. Here, this file will come. Right? So we have our DCD file over here. Then we click on plot result. Fantastic. So this is how you get your RMSD. You can see here as the time frame. Time frame is nothing but a different way of showing the time steps. So each time step, all these 2500 time steps are divided into 10 frames. So it gives you in short a time step analysis versus RMSD. So you start from here, you can see here, it goes till this value, and after around 6.5 time frame, it has reached 0, and this is how our trajectory has moved. And then it has achieved certain stable value at the end. So your RMSD should reach a certain stable value. Then you can say that system has achieved stability. Okay. Now we will see graphically also. For that, go to graphics, representations. Then we have certain parameters that need to be changed. Select the coloring method as RES type, drawing method as tube, go to trajectory. Here we put some color scale values. These are the standard data ranges, 0.40 to 1. Okay. Then you set it, go to trajectory. After you apply this set, selection has been done. Then you go to here, graphics again. Then we go to representations. No, sorry, graphics and colors. In this, we will select as we have already selected residue type and color controls. Cube is selected. Yes. Now you can see how beautifully it can be seen. This is our protein after simulation in the color scale. So blue color always depicts highly motile atoms, red color with less motile, and gray with very less. So this is the protein structure after simulation. You can also see its motions, like I'll keep this open. Now you can see with the help of one visualizer tool known as Movie Maker, make a movie. Click on play. You can see how its motion occurs from time step to time step. And this is how your molecular dynamics is applied from time step to step. Make a movie. Fine. So this is how you perform the simulation. This is for water sphere. Now let us see if our files have generated. Fantastic. Simulation has been completed because how do you see if the simulation is completed or not? You can see it through this. If it shows the name of the directory 12 sphere in which you are working, after the blinking symbol, that means your files are generated. Now simply type dir and enter. Fine. So you see here all the files have been generated. 11 output files. Now you're getting me how to connect it. I show you directly to save the time. I showed you directly the DCD file. So this is how you get it actually. So you can see here the DCD file which is generated right now and the log file which is generated right now, isn't it? So now you have to apply it when you are doing. You should get this 11 output files and you are going to load the DCD file and you are going to load the PSF file in order to analyze your what you say protein after simulation in the VMD. Okay, so we have done water sphere simulation and water sphere simulation in the non-periodic boundary conditions, and also we learned how to analyze it in RMSD. Same way, since we have time, we have reached and completed the demo in time. I'll also tell you how to use this in Excel. You can open this RMSD DAT file. You can see here this RMSD DAT file in Excel directly, and you can see the same result. Okay. So you can try that also. I'll just click on next, next, finish. So it has entered all the values. Then one by one, I have to enter 0, 1, 2, 3. Sorry. From the first column, yeah, 0, then 1, then 2, then 3, then 4, then 5, 6, 7, and 8. Okay. After that, we will select this, insert charts. You can select any chart that you want. Select. Any chart type that you are comfortable with Excel reading, you can select. You usually go for XY scatter. XY scatter we will select. It will give you the graph of RMSD versus times. Okay. Yes. So like this, I've already saved some results. RMSD of PSF generator, that also I've saved. These are the results which we got now. Now, I'll just tell you the commands for water box. You will have to perform in the similar way, whatever we have performed for sphere. So for the box also, only the thing is there will be change in the commands. Okay. So for the water box, commands will be different for generating as we access in the TK console. Remember, in the TK console, here we accessed through water sphere scripting. So I think I'll show you that also, how to generate a water sphere. For that we have different command. I'll just tell you how to solve it. Other rest of the everything is similar, so you can perform it also for your own. I'll just tell you the command of water box solvation, and if you want you can note it down also. It will just change because the dimensions of your water box will differ. Here we previously in sphere we did not give any dimensions, but here we are going to give dimensions to proteins. So first make sure in which directory you are. We are in 1-1 build. So yes, so in 1-1 build, what we will do is we'll write a command package require solvent, enter. Then we will write solvent UBQ dot PSF dot space UBQ dot TDB space. Very important thing now. Minus T 5 minus O UBQ underscore WB. Okay, enter. Fine. Okay. Package requires solvent UBQ dot PSF space UBQ dot PDB minus T 5 minus okay, fine. Yes, I should retype this command. Wait, I'll retype it. Package require solvent, enter. Then solvent UBQ dot PSF UBQ dot PDB space minus O UBQ underscore WP. Fantastic. One mistake I had made. Instead of minus O, I had typed minus 0. So good it happened in fact, because you should understand you're not allowed to do that mistake also. That is also common mistake done by participants also. So here now I have completed this solvation in water box. So you have seen solvent completed successfully. Now, the same way you have to check with dir command whether your water box files are generated or not. You can see here UBQ underscore WB dot PSF is generated and UBQ underscore WB dot PDB is also generated. Now you can go ahead the same way as we performed for sphere with the water box files. Since those are generated, you can visualize them in VMD. Also, you can analyze, you can run the simulation for water box, but remember that will be in 1-3 box. So you have to access the same way as we had access to 1-2 sphere through NAMD and VMD. And you are going to perform your simulation in the same way. Command will also be the same. Only the difference will be instead of WS, you will write WB. Enter and run. You'll get 11 output files again, but those will be generated in your NMD tutorial files 13 box. So you'll have to look for the files. Again, in the same way with the water box, you're going to load DCD file and you're going to load TSF file. Then in the same way, we will analyze RMSD and the log file. So all the protocols remain same. So I hope since we have done it very gradually, step by step, you must have understood the flow or simulation protocol for sphere in the same way you perform for box. Okay, same way you will analyze the results. Fine. Yeah, now I'll show you how do we see this output files in 13 box. Yes, so these are our box files. So this is our log file, text document, and this is our DCD file, water box instead of sphere. The same thing which we have done for sphere, you are going to follow for water box. Yes, so this is all about the theory and simulation live demo. I hope I'm successful in making you simple to understand what is simulation, how to run it. Now, what I would like to do is I would like to ask if you have any doubts, if you need some further guidance in the same topic. I'm done with my explanation part. Yes, yeah. So now I will see the chat box for the questions from the beginning. Okay. From where we get this tutorial files, can you please share the link here? Yes, yes. Okay. I will share the links. Can we have notes for the step-by-step procedure? Sir, I would like you to invite for our workshops where I give you hands-on training. One by one, I make our participants to share the screen and teach them how to do it one by step. I can provide you with the exact notes, but uh, I can provide you good training in our workshop. So you can please go to the website and check the upcoming workshop for simulation. It is planned in January, so you can always attend. Okay, so fine. First, I will put or else I'll show you since we have time. I'll show you how to install NMD, VMD, and NMD tutorial files from the website. Okay, wait. I'll start my sharing my screen again. Okay, fine. So we will do installation part so that it gives you confidence. Okay. No problem. So we'll go to Google. I'll tell you how to install correct version. Simply write NMD. Go to this NMD page. There is a lot of load on this server, so sometimes it is little slow. Yeah. Now here you have to go to NMD. Fine. Then it will take you to this page to go to download NMD. That will give you some formats compatible to your system. You have to select. So as I told you, my system is Win64. It is that is in detail it has given version and platforms. So my system is Win64, Windows 7, 8, 10. So I'll just click on this. Then you have to register with your username. This actually I have installed it already. So okay, we can do it by some other username or do it for yourself by giving, since I've already installed it, it is saying me that your registration name is already taken. So use some other name, create a password. I'll put all the details. Re-enter the password. Register. Email address. Re-enter the password. Access approved. Then I agree to the terms of license. Software download. See here at the down, you can see your software is getting installed. Fine. So there was one participant who was saying that your version is not correct. You must have selected some wrong version. You just have to see if it is 2.14 Win64. Okay. So might be your system is 32 and you are trying to install 64. That is a problem many a times. Now you have to simply extract. You have to simply extract this, okay, in the folder. So you'll extract it in the D drive, right? This is how you install. Same way you installed VMD and same way you installed NMD tutorial files. Okay. So I'll show you VMD also. VMD again you have to, you can directly go from here also. VMD. Download VMD. Here again, correct version of 64. Yes, this you can click, or in this one. Same way you have to register. I will not do it again. You have to simply click and it will install. You have to fill all this information and you have to simply install VMD. And as I told you, it will be automatically installed. You have to just type in the search as VMD and it will be accessed automatically. Right? Now I'll show you NMD tutorial files also. Yes, so now it will take some time. Now, this is for single protein, right? So till we have time, I would like to discuss some few things also about the simulation. This is for single protein. Nowadays, after the pandemics of Corona, this simulation has got importance as a complex simulation also. So along with the protein, ligands are studied and compared with the docking studies, simulation studies. So simulation studies, if you provide with the analysis of docking, these results are of high importance in from the research point of view of drug designing. So the complex simulation also is done in the same way, only the thing is topology file which I showed you is for the single proteins. So the challenge in front of us is always a preparation of ligand simulation file. Okay, so that complex simulations have got a lot of importance nowadays in drug discovery. Yes, so here can you see many times common mistake is done by selection of wrong this thing, wrong link over here. You have to go to this particular link, NMD tutorial zip 155M. Once you click on this, can you see at the down, this zip folder will come. You have to extract the files and all these files will give you the folder which I had shown you. One build, one to sphere, everything will be there. Only the thing is you have to extract that NMD tutorial zip file into D drive correctly. Okay. Okay. No, dear, you can't get the presentation. As I told you, I really welcome you all. It will be great pleasure for us to teach you exact everything in detail about the simulation. So this was just a live demo, and I can call it as a trailer. You can join our workshop where I will teach you hands-on. And see, I'm not on the boasting at all, but we train in our workshops the participants in such a way that for us, researchers and research fellows come who don't even know how to use the computer. So right from opening the command prompt, we teach you everything, but we really can't provide you with the ready-made material. We will not provide the presentation slides, but you can of course join our 7 days workshop for simulation. We are also planning to include complex simulations also, so you are most welcome for the workshops which are taken, and the links have already provided, I think, in the chat box. So please visit our website and also see the other modules which we take, like molecular docking, QSAR, basics and advanced bioinformatics, everything. Thanks a lot if you like my session. And Lena, I didn't get you actually. What is expensive for you, like attending the workshop? You have put in the chat box. Okay, fine. So I believe this 2 hours were productive and everything is clear. Still, you guys have time, so you can ask your doubts. Otherwise, we can end the meeting. I hope I was slow and very much clear for you, because this simulation, people already have fear of bioinformatics because they say, see, they find this is something very new, and new, more than new, it is something very difficult. It is not like that. Running the commands of NMD simulation also is not a very difficult task. It will, you will be comfortable when you practice it more. Okay. So uh, I think I have made it simple for you to understand today, and I have been successful in the process. So I would like you to see in our all the services which we offer. Okay. From where to open VMD command line? Yes, I'll show you once again. When we use sphere or box solvation, yes. So I'll tell you, box solvation is compulsory, but sphere simulation you can skip if you are in hurry, or if you don't want it. So it is box simulation is because of the periodic boundary conditions you are putting. It is important, so you have to always do box simulation. And what is the benefit of doing sphere simulation is, you are reducing the time and load of water box simulation. Because if you directly give the water box simulation, what will happen? It will deform, system will deform immediately. So first you are giving it because it will ultimately take the most stable structures. So it will be sphere conformation only. So what we are doing by giving sphere simulation before is, we are moving more towards accuracy, and we are reducing the computational time and load required for box. But you can skip sphere simulation also. Sometimes you skip it, but box simulation is always done. So every time in the simulation, you have to produce box files and you have to analyze box files. That is mandatory. Okay. Yeah. From the VMD, I'll show you once again. From the VMD, see here, I have this. I'll open up again and show you this VMD. Okay. Yes. So this is my VMD. You have to type and open. Now, once you open it from the main, you go to extensions and TK console, and that will open your command line like this. Okay, here you are going to access and perform all the commands. I'll repeat once again. Go to extensions and TK console. Fine. Okay, you have a query why we use temperature 310 instead of 298. You can use 298 also, but it should not be 310 is a standard which is used. It should not be beyond, or it should be within plus or minus 15 to 310. So you can use from like 295 to 3 310 and 320. You can use it. You can change the temperature in configuration file if you want, but don't go far beyond the limits. 310 is like a standard, so we use it. Okay. Any other query? Yes. So shall we end the meeting? Hope you like the session. Uh, you want me to share some of my articles for study? Okay. You can find it on the ResearchGate also. My papers which are published. Yes, sir. Mr. Junaid. Okay. Yeah, you can access to the papers, tutorials which we will provide in the workshop. Yeah, our team is giving you answer. So in the workshops, we will share all the required papers and materials. Okay. Most welcome, Madhurima. Yeah, it you have to be patient in bioinformatics. Thanks a lot for your compliment. Thank you so much for being attentive. And if you have all noted down the what we have done and you have understood, repeat and try to get all the files and run the simulation. And to learn it in more detail hands-on, please join our workshop. Thank you so much, BDG team. Good night.